Phase transitions. The term phase refers to a specific state of matter, such as a solid, a liquid, or a gas. When a substance undergoes a change from one of these states to another, it is called a phase transition. Phase transitions at a given pressure take place at a constant temperature, and they are accompanied by the addition or removal of heat, and may also involve a change of volume or density. Examples include water freezing or ice melting, water vaporizing, or steam condensing. We're going to focus on phase transitions in water. Now, ice melts at 0 degrees Celsius. For 1 kilogram of 0 degrees Celsius ice to change completely to water at 0 degrees Celsius requires the addition of 334 kilojoules of heat. That's 334,000 joules for every kilogram. Similarly, to freeze 1 kilogram of 0 degrees C water into 0 degrees C ice requires the removal of the same amount of heat, 334,000 joules. The heat added to change a solid to a liquid, or removed to change a liquid to a solid, is called the latent heat of fusion, and we give it the symbol L with the subscript F. So for water, the latent heat of fusion, L sub F, is equal to 334 kilojoules per kilogram, or 334,000 joules per kilogram. Continuing with water, we know that water boils at 100 degrees Celsius. For 1 kilogram of 100 degrees C water to change completely to steam at 100 degrees C requires the addition of an incredible 2,260 kilojoules of heat. That is 2,260,000 joules of heat to take 1 kilogram of water at the boiling point to 1 kilogram of steam at the boiling point. Similarly, if we want to condense 1 kilogram of 100 degrees C steam into 1 kilogram of 100 degrees C water, we're going to have to remove that 2,260 kilojoules of heat, at 2,260,000 joules of heat. So the heat added to change a liquid or a gas, or removed to change a gas to a liquid, is called the latent heat of vaporization, which we symbolize with a capital L and a subscript V. So for water, L sub V equals 2,260 kilojoules per kilogram. Here's the temperature versus heat diagram for water. The diagram starts with ice at a temperature of about -25 degrees Celsius. As heat is added, you can see the ice increases in temperature until it reaches 0 degrees Celsius. After that, the addition of heat doesn't increase the temperature, but converts the ice into water. When all of the ice is melted, we're left with water at 0 degrees Celsius, and additional heat raises the temperature of the water until it reaches 100 degrees C. Now, with the addition of heat, all that happens is the water is slowly converted into steam at 100 degrees C. Once all of the water has been converted into steam at 100 degrees C, additional heat continues to drive up the temperature of the steam. The thing to note here is during phase transitions, the T versus Q graph is horizontal, and during that phase, there is a mixture of water and ice or water and steam, during which the temperature remains the same. The only time the temperature increases with the addition of heat is when it is in a single phase, such as here water, here ice, or here steam. Remember that we pointed out that during a phase transition, the temperature remains constant. So what's happening to the energy? Where's it going? What's it coming from? The answer is that it is going into making or breaking bonds between atoms or molecules of the material. For example, when ice melts, the bonds that hold the water molecules rigidly in place are broken with the addition of energy. When that energy is removed from water at 0 degrees C, the molecules lock in and bond again, crystallizing the ice.